Hello and welcome to another physics tutorial with Daniel. So today we will be covering problem number 10 in chapter 12 this time. So this problem is talking about static equilibrium. So let's read through our question. We have two blocks being supported by three different strings. We have two diagonal strings and an exactly horizontal string, a 40 Newton block and a 50 Newton block, and we know one of the angles. And we want to find these three tensions and also this unknown angle. So let's start with the side that we do know about. So the left side. We know that this angle is 35 degrees. So we can break this unknown T1 into known components. So then this vertical component would be T1 cosine 35. And the horizontal component would be T1 sine 35. Now, because this system is in equilibrium, we know that this little joint here has to have no net force on it. So we know that we have T1 cosine 35 in the vertical direction, and to balance that is this 40 Newton weight in the downward direction. So we know that T1 cosine 35 equals 40 newtons. So then we can solve for T1. And then furthermore, we know that T1 sine 35 equals T2. And because we could just solve for T1, now we essentially know what T2 is. So then what we can do is we take our known value of T2 and split T3 into similar components, where this one is T3 sine theta and this one is T3 cosine theta. So because we know what T2 is, we can therefore find what T3 sine theta must be. And because we also know what T3 cosine theta is, we can then solve for T3 and theta. So let's actually make our equations. So first off, in the vertical direction here, we have the net force in the y direction is 0, and then the forces in the y direction will be T1 cosine 35 minus M1g, MAG, I guess. And meanwhile, in the x direction, it is again 0 because it's in equilibrium, but now we have T1 sine 35 minus T2. We're assuming that left is positive. It doesn't really matter here because it's 0, but alright. So then we can find that T1 cosine 35 equals 40 newtons. So then T1 equals 40 newtons over cosine 35, which is, if we plug that into a calculator, this will end up being 48.8 newtons. So now that we have our value of T1, we can then solve for T2. So we have T1 sine 35 equals T2. So we have 48.8 times sine 35. So now we know that T2 is 28 newtons if we plug that into your calculator. So next what we can do is find the equilibrium equations for this right side. So for Fy, we have T3 cosine theta minus mbg equals 0. And in the x direction, we have T3 sine theta minus T2 equals 0. So here, we see that T3 sine theta equals T2, which is 28 newtons. And we know that T3 cosine theta is 50 newtons. So we can see that if we divide these equations by each other, we get that. So if we move up here, let's say, so we have tan theta, which is sine theta over cosine theta, because we divide these equations. We have this equals 28 over 50. So we have that our theta is the inverse tan of this value, which is, if we plug that into our trusty calculator, we get that theta is 29.2 degrees, which we can then plug back into, say, this equation. So we have T3 equals 50 over cosine theta, which means that T3 is 57 newtons. Alright, so we have our three tensions and our unknown angle. Alright, I hope this tutorial helped you a bit. We talked about equilibrium And just remember when you're solving these problems to set up all your different equations for x and y directions and torques, although there wasn't any in this problem. Alright, thank you for watching. Bye.